So in example 5, it says, given the graph, write the inequality. Basically, this is really finding the quadratic equation problem. And I can find the quadratic equation. The easiest ways are to use the graphing form, which involves the vertex, and I can definitely identify the vertex. Or I can use the factored form if I can identify zeros. So I can identify zeros here. So I have actually two options. They're both perfectly fine, and they will both work. So we just have to decide which one do we favor, which one do we like to do. So I'm going to stick with the graphing form. So I'm going to write my graphing form equation. I'm just going to write it as an equal first and then work out the inequality after. So my vertex is going to be at positive 3, positive 8. So I need to write my graphing form minus 3. Remember to square it, plus 8. And then I have to solve for my a value. And I can solve for my a value. I can use one of the 0 coordinates or any other coordinate, but those ones look very convenient. So I'm going to use this one here. It looks like it's at 5 and 0. Okay, I could have used 1 and 0 as well. I'm just going to happen to use 5 and 0, so I'm going to plug 5 and 0 into my equation. When I do that, I'm just left with the a value to solve for. So solving for a, I'm going to subtract 8 from both sides. I get 5 minus 3 squared is 4. So I get negative 8 equals 4a. So a is equal to negative 2. So at this point, I have solved the equation of the parabola. Okay, so I've used the vertex. Again, there's a lot of this idea of, this is from chapter 3 and 4, where we have to come up with the equation of the parabola based on some coordinates. So my equation is going to be x minus 3 squared plus 8. So the vertex is at 3 and 8, and it's got a negative 2 leading coefficient. So there we go. Now, at this point, I need to decide what my inequality is going to look like. Now, I am below the line. The shaded area is below the line. So that means when I write my inequality, the y must be less than the line, which is negative 2 x minus 3 squared plus 8. And I don't make it equal to because it is a dotted line. The dotted line means not equal to. If it was a solid line, I would put the little equal to there. So there's my final solution. I've got the equation of that line. I found using the vertex and the y-intercept. And again, I didn't do it using the zeros, but I could have used the factored form and come up with the same equation in factored form, but it's the same equation. And either form is perfectly fine for this question. So again, in this question here, although it's a two-variable inequality, we want to graph it, we basically need to graph a parabola. So I'm first going to focus on how to graph this parabola. Now, based on this equation, I can use, I do have a y-intercept of negative 10, 0, negative 10, but really I want either zeros to get symmetrical points, or I want the vertex. So I can complete the square to get the vertex, or I can factor get zeros. When I look at it by inspection, I can see that this is probably easily factorable. Two numbers that multiply to negative 10 and have a difference of positive 3 are going to be 5 times negative 2. So what that means then is I can come up with, from the factored form, I can come up with two coordinates. And they are symmetrical coordinates. So I'm going to have a coordinate at negative 5, 0, and I can also have a coordinate at positive 2, 0. Okay, so those are some coordinates I have. I can probably find a symmetrical coordinate. So I'm just going to draw this in, positive 2, 0, and negative 5, 0. I know it faces up. I've got a y-intercept at negative 10. I'm just going to sketch that in. I probably want another symmetrical point to that, which I could do. I could also just find the vertex here. So I think I might just find the vertex. Okay, so I'm going to just move that over a little bit, and I'm going to find a vertex. Okay, the vertex is going to be in the middle, so the vertex is going to be halfway between -2 and +5. So -5 plus 2 divided by 2. That's going to give me -1.5. So at -1.5, I have my vertex. Okay, I need to just get rid of this color here. This is a y-intercept. Okay, so if I want to find the y-coordinate, to find the y-coordinate of any equation, I plug in x. So x is 1.5, so y when x is 1.5, I'm going to get a coordinate at 1.5 squared plus 1.5 times 3, sorry, -1.5 times 3 is going to give us -4.5 minus 10, and then working this all out, I'm going to end up with -12.25. So -12.25 is going to be my coordinate. Okay, so -1.5, -12.25 is right about there. There's my vertex. Okay, I'm just going to put one more coordinate in here that is symmetrical at -3, -10. So the -3, -10 is going to be a symmetrical point to the y-intercept. Now I'm able to draw my parabola. Now I can kind of focus on the inequality. It is not equal to, so since it's not equal to, I'm going to draw this as a dotted line. So it's going to be a dotted line through those points like that. And I have to decide, am I above or below? So since it is y is greater than the line, I'm going to shade the area above the line. Okay, and again, we're not doing inside and outside, we're doing above and below. So there is my shaded area. It's the area above the line. I could test the coordinate as well. This is not necessary, but I can always, if I'm not sure, I can always double check. I can test a coordinate in the inequality. So I'm going to test 0, 0, which is the easiest coordinate. So I get y is greater than 0 squared plus 3 times 0 minus 10. 0 is greater than -10. That's correct. And that satisfies the inequality. It is in the solution space.